Alrighty. In theory, we should be live. I'll just fuss around with some more things, and we'll see how that goes. Yep, indeed, I do appear to be. As usual, I'm going to just get everything sorted together here, as I want to do. Here. Hi. That's my other camera. I haven't got the contrast set up for it, but should be able to get into studio jams again at some point. I have been putting a lot into getting ready to do that. But today I am exhausted because of, oh, I think I can give myself a little bit more volume. There we go. How's that? Yeah. That ought to be enough, I think. So I am exhausted. I've been trying to get the Mac M1 stuff going, and that is a interesting process, to be sure. I'm on the Apple Developer Program, and let's see, are we still streaming? Yes, I believe we are. I'm on the Apple Developer Program. I have paid money to do that. I've also paid money for several applications that are supposed to help you through this kind of stuff, and indeed they do seem to be helpful. Unless anything terrible goes wrong, I would recommend them. But for now, I am waiting to hear back from the guy at Apple who knows about Gatekeeper, because I'm talking to people or one particular person at Apple, really, and they're like, can you build a test application and export it with notarizing? And I'm like, yeah, here, let me do exactly that. And can you export it without sending it directly to Apple and then send the DMG file? I'm like, yeah, funnily enough, I can do that too. So basically, it's like, I got to walk through this stuff. You deal with anybody in a situation like that, they're going to treat you like an idiot because they have no real way of knowing that they're not dealing with an idiot, so it's kind of only fair. I mean, it's a little bit annoying, but by the same token, in many ways, like not being able to figure this stuff out off the top of my head, I do feel like an idiot, so it's all good. I don't know how much time I'm going to be able to spend doing this, but a certain amount, I think. I do have a project that I think I might even be able to get a result out of in the 2 hours I'm going to spend. I've got a number of things going on. Even if I have no actual viewers, I guess I'm going to wait and see whether any... Oh, here's 2 people. 3 people. People will show up eventually. I can't really tell. Seeing as I don't do Twitter or Facebook anymore, I can't really send notifications anywhere. So it's more or less, are you watching YouTube and do you know that I stream at these regular times? And I was a few minutes late, but not terribly. I was keeping track of the issues for this new M1 port this morning, even posting cries for help as early as this morning and getting some responses. So it's like, well, there's a dialogue going on, and this is promising. It might actually go somewhere useful. Speaking of somewhere useful, let's just fire this up. Hey, Lorenzo. Oh, hang on. There was one further thing. It's been a little while. I have almost forgotten that I do this. Hi, chat. No, I could. Hang on, that's not the right thing. Might be worth making you folks a little less transparent. Filters, is it? Yes, it is. So if I fool with that, chat can be much more visible. Yay. Funnily enough, I can do Luma key and other stuff as well. Now that I'm not trying to get the webcam output of the 810 Mini, it has come in real handy. And there's all kinds of nice stuff we can do with that. Like doing insane things with this kind of stuff. You know, there will come a day when we sit down and I fool with, let me give them my image in there. When we sit down and I fool with this kind of thing so that people can enjoy the end result of playing with these funny graphics and things. Because I finally have my Sleepy Circuits Hypno back. And that is what's doing this freakiness. I have it doing an elaborate video feedback shenanigans. You can even see how this little window here replicates itself into the rest of the video world in a bizarre and crazy way. And this is all stuff that I can do with the Hypno and the ATEM and sort of my whole video rig. So I feel like there's fun to be had here. Definitely kinda more in a little freaky madness. All in good fun. Yeah, and then if I do this, we can get really unorthodox. Yeah, so don't mind me, I really shouldn't be fooling with this when I'm supposed to be doing the coding stream. But I've put a fair bit of effort into getting this rig set up. And it is most definitely set up. I'm going to be putting these things into the backgrounds of my video streams to make them more interesting, so when I have plugins to post. Oh yeah, no, it's all about, it would make a dandy music video, do this stuff right. The video feedback stream, I can actually get this particular webcam. Here's another thing that I've tested out. It probably won't work straight off, but I can do it anytime I like. This is a Razer webcam. It's the kind of Razer webcam that has a light built in. This is a ring light. and it's pretty close up. It's, let's see, it is a Coils. And you got these funny mounts and things. But what you can do here is you can plug this into the same place that the video feedback is plugged into. And then when you do that, you can like hold it up to your face, it lights your face, and then you can have these insane video craziness things, like all this weird fractal stuff and so on, like a kaleidoscope, but with a live camera. And then you can hold it up to literally the screen that's displaying it. I'll hold it up to the image of OBS. And it's an alternate way of getting insane video feedback, slightly less, it gets extremely blurry and messed up, but that gives you even more insane video textures. And the thing about it is that the video textures are running at like, I think it's about 30 FPS at the ATEM will do. The whole thing runs very seamlessly because none of it's actually compressed. The Hypno is doing a raw HDMI to the ATEM Mini. The ATEM Mini is going to the Razer Capture, and the Razer Capture is running at top speed itself. So yeah. You get a bunch of funky craziness. And I think this is so much fun that I'll probably see what I can do as far as communicating how these kinds of things are done. Look, here's an inverting version. And you can dim it out, distort it in weird ways. Positive. So, yes, you can see these are and make it much smaller. I'm not sure whether I can put a voltage into this and make it bigger. Might be an update. There was an update allowing it to do this video stuff, which is very neat. And yeah, like I said, this kind of thing is a lot of fun. Here, what I'm doing now is I'm using the video stream to modulate the video stream. So it looks kind of underwater now. The pattern that you see is literally this video image as frequency modulation on the video itself. And I can also make it be not so much frequency modulation as just another like we can get really weird really quick. So yeah, I got one of these when it was fairly new. And it was at a time when there was an issue with how they were made. So that there was a jittery quality to it. Like you could set it up to do something like this. And as you can see, it's relatively stable. Stable might not be the perfect word for it, but we can do this kind of craziness. And as you can see, it's a little flickery, but it is sitting there and not having like big horrible twitches. And the version that I had, it was going. It would do this, and then every now and then it would. What would be better? It would do this. So it wouldn't be able to stay with what it was doing. You get these twitches. I'm modulating some controls to make that happen. And that kind of limited things somewhat, because we've got all of this like bad craziness going on visually, by all means. Like I said, bad craziness going on. And you want that part to be stable, but having the whole thing twitch at the same time got in the way. And what I was able to do is send it off to the company again, because they had a version of Sleepy Circuits Hypno, which is what this is, where they had power supply in there that was not what they wanted it to be. They were seeing a lot of success and had people building them for them, and some of those that were built had poor power supply, and so what they did was they did a recall. And the recall meant that you could send your instance back to home base, and they would do it at no charge, but I kind of express mailed it to them, and they sent it back with the little box that I had originally gotten it purely for Eurorack purposes, and it didn't have the capacity to have a little box. But I got that afterwards, and yeah, I have to say I'm quite happy with it. It is a very cool video jam thing. Like, I feel like I could be a rave visual artist doing this kind of wackiness in a big screen or a projector. You can go chill with it. You can get more extreme. Or we can get back to what I was actually doing, because the deal here is now this is just running, so I get to use it anytime I want for my regular stuff, and its normal behavior is more along the lines of, well, that looks kind of crazy. Oh, I know what's happening. See, I'd need to have the display set up so that I could show the basic purposes. And the deal with this is I just started talking about my Sleepy Circuits Hypno, which is a crazy little device that I got for the purpose of doing this kind of wackiness. And this is not code. This is like a little Eurorack device that you can also get in a box. It's not cheap, but I think it's one of the better ones of this kind. It's basically a proprietary little Linux box in some kind of Raspberry Pi deal. And there is a visual input, which is this. and I have it feeding back on what the output of the video feed is. So when I run it into the switcher, and then I use the switcher to also overlay a camera onto it, what we get is like this. You can switch to the camera, and then switch to it, and it starts going weird. And then if I overlay something in the switcher, it incorporates that into the feedback. So there's a lot of fun things that you can do with this type of silliness, and I intend to do all of them. But today, pretty much what I'm doing is just like, it's no wonder that I'm playing with the toy. I'm exhausted. I had been porting 248 different plugins for the purposes of releasing them on the Mac M1, and it has been so exhausting that clearly all I want to do now is play with toys. But I am going to do a little coding too. Like, we can get into that now. Because the Hypno is just like a little Raspberry Pi thing. It's not even drawing that much power, and it can just sit there. It's one of the video inputs that I'm not using. And everything about like the USB camera, that was how it got the feedback video signal back in. You know, some of this stuff is stuff that I'm certainly going to share as far as I was asked, because this morning the Patreon hit that $2,000 mark, meaning that the DIY circuitry building is going to begin. I figure it can begin this week, except for I don't expect too much out of it immediately because I haven't actually started yet. So what we're going to be doing is like building a power supply and stuff and getting the camera so that you can see what I'm doing. And I'm probably going to start with tube sound fuzz. Tube sound fuzz is a circuit that you can make out of a 4049 hex inverter chip. And that's what I started with. So I'll start this with it as well. But I've been having some fun with, even this morning, I was looking up things like the schematic for a Clone Centaur, because talking about the plugins, I was like, yeah, now people want an SP1200. Next thing you know, they'll want a Clone Centaur, because the deal is if I have to have those things in order to know how they work, in order to be able to demonstrate them properly. Much like, here, let's work out that this is actually playing. Yeah, here we are. Much like this. This is kind of what we're doing today. These are the filters. Except for this is not what we're doing today, but we'll get back to it. And that's a real Mackie 1202, and I needed to get going working with the actual device in order to really understand what it did and what was possible out of it. It would be the same with the classic sampler as well. I haven't done that much with samplers, and it's probably time that I did. But what I was thinking of doing today was different, and it doesn't involve the endless grinding away at the M1 laptop trying to get everything to compile. I've been doing that for more hours than you could possibly imagine. Oh, your links didn't come through? Yeah, to some extent we're stuck with what YouTube will let you do, so they probably have some kind of terrible thing that they're doing. But yeah, what I thought I might do is I was making some notes in my usual trawling around and figuring out what I was doing today. I was looking up stuff like, what makes a Klon Centaur special. I was looking at the schematic for those, and oh yeah, OBS stream effects and shader filter. Yeah, I'm not doing that stuff that way. My stuff will look different than that, but I think it's really cool that people get to do that stuff, especially if it's like open source software and it's accessible. That's why I'm continuing to do plugins. What I'll be working on today that hopefully isn't going to be too exhausting, because I'm already exhausted, is I'm going to revisit Coils. Coils was meant to be a transformer emulation. And here's my original drum track. And if we go to effects, I bet it's in this list. It's one of those things that we've forgotten was there. Here's Coils. And what Coils is, it's meant to be a transformer emulation. Thing is, I don't think it made much of an impression, because it doesn't sound very different. I feel like I can take this farther, but there are things like and these things are changing stuff, but the reason Coils was not a big hit among people, I think, is because you couldn't really tell what it was doing. It's too subtle. So I should be able to look at that. And here is see, it does do something. And I can show you what it did. And I can apply this and then zoom in. And you can see that something funny is going on, but I'm not really exactly sure what the deal is there. Because here's the thing. I'm going to probably be wanting to revisit it. I'm going to need to be able to smash the gain on it a little bit harder. And the notes I was making here had to do with a thing called transformer hysteresis. Transformer hysteresis loss modeling. So, as one does, right? So here we're going into our, oh, hang on, I'm not quite done. I'm pretty sure I can do this with that issue. Oh, except for maybe not quite. Hang on a second. I'm actually going to quit out of Xcode for this as well. I need my Wi-Fi just for a moment, and then I have to remember to turn it off again, because several of my virtual machines break if they have access to the internet. But as you can see, we are receiving stuff. It's a big list of stuff, and it's now done. And here's what we got. We got this. And among them, this is the process that I have to go through for making all of these AUs. Works kind of like this, or it would if I made the window a little smaller. There we go. So here's what I do. I'm using BBEdit, I'm using Apple Developer, I'm using DropDMG, and there's also yet another one, Sign something. Yeah, SD Notary, which also costs money. These are all to make it a little easier to deal with this stuff. So the first thing I do is copy the folder that we're going to be dealing with on this older computer over to a new location, because I have to continue to make the older stuff for older machines, and I just prefer to. We edit a plugin CPP file. I can go back to here and start bringing this stuff in, and I'll show you all the things I'm talking about. Now we have the Mac signed AU. This is the new stuff. As you can see, it looks pretty much exactly the same, but it's not. It's very different. And Coils, let's open that. So one of the first things that we do is change this part here. So it says audio component entry, AU base factory, comma, there's a space there, and then this. So that gets edited, not here, but on the new version. Then we edit plugin EXP, which is this. And instead of just saying Coils entry, it says the second thing, which is Coils factory. It'll say Coils entry, and then it'll say Coils factory. You can do an elaborate find and replace making this happen, but careful not to run it on the entire code base. Then you find in the info plist file, and that is this. And I like editing that in the text editor for this, but it has this stuff in here. And what I need to do is add this thing, which is a dict, and it has this XML, and it adds these things, which are kind of similar to what you see here. It says stuff like product name identifier, and that'll just put in what the name of the plugin is. It's doing all this, and then this question mark area needs to become what lives here, which in this case, it just says coil. That's the ID. We haven't even opened up the project file yet, but this is what I've been doing all week. So that's why I'm talking about it. You open it up in Xcode, you delete these folders. These don't work in the new machine. They're here in the existing machine, and they're here in this version of Xcode and stuff, but open it up in the new machine and it don't work at all. So you have to get a new copy of all this stuff from a newer version of the like audio toolkit kind of stuff. Drag in the new SDK, do those things, then change all of these little settings in the Xcode, which is kind of like this. In this one, I've lost track of how we do this. In this one, there's a different way of doing it. Here's the configuration. As you can see, we have 3 different architectures that we're building. In the modern version, we're going to do 2, which is Intel 64 and the Apple Silicon stuff. But they don't let you do any of that other stuff, which is why I'm still building these. And goodness gracious me, what am I even talking about? Page? Nope. Oh, I remember. So in this one, in order to work on this stuff, what you have to do is go get info, and I didn't open it in the right place, so it shows me nothing. But then if I do get info on this, in the new version of Xcode, this is all in a different place, and it's arranged in a different way, although there's some similarities. And you got general, which is like the name of the thing, and then build, we have an area which is all full of stuff like this. Most of these things are meant to be different, but it's hard to tell exactly how different they're supposed to be. You still have stuff like product name, and if we edit this, it changes things in a bunch of different places. And in like this stuff here is all the little details that I have to change, which this is not finished. There's more that I need to do because it's still not working. I've done this for 248 different plugins, but I try to keep it very regular. And yeah, that's a target info, but we can also do the project, and the project info is like this. You can see I've got a base. Yeah, Coils is the transformer. Coils is also very subtle, so we're going to be changing that a little bit. And you wind up doing work with this kind of stuff too. There's general. Some of this is not all that. See how this has a base SDK for all configurations? And then also in here, we've got other places to set the same kind of thing, except for not really there. But then over here, we've got this, although it's also in that. And then we've also got it in the target. You can also do things like architectures. And this has a base SDK, which is different. And I don't really know exactly how that all works out, except for that it works. So this coding for Apple is kind of like this. Coding for anybody is kind of like this, but coding for Apple is very much like this. So, set all that stuff up right, which I have not, but I have, like, you search out things like, it says search paths, always search user paths. That's a little setting in there that you have to set to no from yes for all the 248 different project files, because it throws an error if you don't, and then you have to look it up on Google and be like, what happens when you get this error? And somebody somewhere said, oh, you have to set always search user paths to no. And I'm like, okay. And you find where it says always search user paths in build settings in project, not target, but project. And then you set it to no for all 248 things. Good thing is, once I've done that and written it all down, this is live on the internet, so you can look this up too. If I'm able to do that, other people will be able to follow. I will have given the information that you need. You also have to punch in editor search paths and this kind of stuff. You will be wanting to change that to who you are, of course. And then once you've done all that, there's a new way of building the stuff. Product menu archive. I assume it's a new way of building the stuff. Is it? Yep, there's nothing that says archive here. There's always all this stuff that you don't actually use and that's really confusing and weird. Like here's a organizer. What's this? I don't know. I don't open it up. There's nothing in here. That does say archived applications, but I have no idea how you make that work. So we'll close that again because I've never used it. So yeah, this is what coding is like. That's a that's a log file. This is not secret information you're not allowed to see. This is Apple saying, yeah, the stuff that you did doesn't work. So we're working on that part. But people might actually be able to use the plugins that I posted on Sunday, kind of late Sunday, because all you have to do is get past Gatekeeper. All this trouble I'm going to is to make stuff that just works on the new machines, and that turns out to be the hard part. But yeah, and once I've done some other things like fiddling with all the Xcode settings until they're right, some of this stuff is easier. Like I'm building all of the plugins one at a time. It takes hours and hours every time I change a little thing. I have to go through hours and hours getting RSI in my clicking finger, because I don't know how to script Xcode to do that properly. But once I've done that, the archive, distribute contact, export build products to distribute folder, which I made one on my desktop. This has the entire path to where it thinks the thing belongs. So it has this copy of like user library, audio, plugins, components, and stuff. And then that's where the component files sit. So what I do to deal with that is I'm running this program, but I'm doing a lot of stuff with the terminal. So I'll go cd to desktop distribute so that the terminal is sitting in the right place because it cares about where it starts. And then I do this thing called find, starting with dot, which is starting where you're at. Otherwise, it'll just start at the root level. And it finds names with anything followed by dot component. In other words, from where I'm starting, it looks inside there and goes and finds all of the plugin files. And then exec means run this program. And it runs a program called dropdmg, which makes DMG files and code signs them and stuff. The config I'm using is Airwindows, and this is what find does to run the thing with whatever it found. You patch in, this punches in whatever it found, and then once it's completely done, it does that and stops. And once I've done that, dropdmg is set to make its disk image files in another little folder on the desktop. So then I have a giant folder with all of the stuff ready to upload. I don't have to dig it out of subfolders or anything like that. So terminal is good for that stuff. And again, find name component. Excuse me. I am really tired after all of this stuff. DMG with all the contents in it. And then here's another thing that you can do, which is if I want to copy just those files out to another folder and then make the DMG with just everything in the folder, I can run that and do the find, but instead of doing exec drop DMG with these parameters, I'm doing exec cp-r, because these component files are like subfolders with little things in them. But when I do that, it copies all of the audio units to this desktop place. And I end up with all of them copied into a place. I just run this once and boom, it does everything. That kind of stuff is handy. That is, coffees, I've already had coffee today. There will be other weeks when I'm more cranking and livelier. I think I can probably get us started on Coils too today. I'm just talking you through this because this is what I was doing all week. So as long as I did that, I'm going to inflict it upon you. So we got that, and then there's not enough. So we do yet another helper program using the DMG files we've made. It's a thing called SD Notary. It seems to work. I did this test application. If you want to work with Apple stuff, and you're not doing something weird or with backward compatibility, they're actually pretty good at setting stuff up. You can do a example project. It's being Apple, when you set up an example project in the new Xcode, you're not programming in C or C++, you're programming in Swift because they invented a language, so everybody's expected to just use that, right? But so you automatically do something in Swift unless you know how to do stuff very differently. And it defaults to this little thing which opens a window and goes, hello world. And you can just build the thing and go. And it makes this little program that goes, hello world, written in Swift. And it's set up to go and it just works. And then you can export that as a signed application and stuff, and that just works. And then you can do the drop DMG if you want, or you can upload it directly to Apple to have it packaged for you, and that works too. And then you can do the SD notary, and when you're doing the application written in Swift that Apple gave as an example, that just works too. It's like, I don't know why the guy was asking me, can you do this simple step? Because it's like, yeah, it's incredibly simple, as long as you do it exactly the way they wanted. But the plugins just died with these problems, and that's where we're at. I tried Aura, because the first thing that I did was I tried to do the larger collection of all the plugins, and that took like half an hour for Apple to consider, and then it still died. So I started testing out the individual plugin downloads. I ended up uploading those in a broken form, and then I did not end up uploading them again on Sunday, so I've just got the big collection on Sunday in the not code signed properly version. I mean, it's code signed, and if you run the relevant terminal things, it'll claim that it's code signed, and then it fails. So I'm still talking to the guy at Apple about what to do about that, but hopefully that'll help. But here, we are on a different zone today. We are on build an audio unit. It's not going to be stereo. This particular formulation, when I tell it to be CocoView, instead it's just building a stereo organization. And we're going to do Coils 2. Kind of like Seriously and Seriously 2. Seriously is the incredibly subtle one, and Coils 2 is going to be the one that gets much funkier. And here we have it. So the next thing in line, because what we're going to do is we're going to get this stuff going, because what goes on with a transformer is a thing called hysteresis, where you end up making wave shapes like this, because as you are, the way that I'll talk about it once I have things a little bit more built. Summing Mixer plugin, that would be console, some variation of console. So you're not likely to see a Summing Mixer plugin, because that would literally be console. Let's see, where are we at? We're going to copy over some of this stuff, but not all of it, but some of it. Here's Coils 2. I'm going to move Coils 1 under chat, because I don't actually need all of that. Here we go. And we don't need this open. We made this on the desktop, so this is our new plugin that we're building. Nothing much to it yet, but we're going to build it from scratch. And here's how we start moving stuff over where we can see it. If I was going to clone Coils, it would say this. But instead I'm making another plugin similar to it, but the next one along. So instead I'm going to change this ID, so it's not claiming to be the same ID, and it'll be Coim, LM. Mostly I'm trying to do the most obvious first few letters, because then if everything is sort of alphabetical, let's go back to this. Yeah, that's the thing. It's like, you should be able to run your DAW as the big console and put the individual parts wherever you want. You should be able to make like a virtual mixing desk where you can stick, yeah, I've just brought the screen up. Now you can see that I have called it Coim, and I'll hit save. Yep, that is literally what I'm doing today. I might even be able to get a start. I've got a little more, just a touch more than an hour to kill. I got something else going on this afternoon, so I can't stay for extra long today, but also I'm really tired, but this is a start. So here's Coils. Here's what we've got so far. We're going to maybe copy over these things, or maybe not even bother, because Coils 2, the template, has all this stuff in it. It's much bigger. So what we're going to do is leave these here so that I can have other knobs to fool with as I dial stuff in and make it all work. But what we are going to do is copy whatever this was. Long double figure 9. See what's going on. The reason I'm calling that figure is because the way Coils works is it's like doing the unbox thing. It's doing a distortion, but it's kind of like unbox or focus. Those have a distortion that happens only on the mid-range. And they exist to show what it's like to be able to boost only a mid-range area and then distort it, meaning that the frequencies that you get out of the distortion are going to be anti-aliased. Because no matter what frequency you run, it's going to resist giving it higher frequencies that would alias. There's a filter in there. And the way that stuff works is it takes the mid-range, just only the mid-range. It distorts that and not anything else. And then it overlays like a dry-wet kind of thing, where you've got the distorted mid-range, and then you've got the everything else, which is the raw signal minus the mid-range. And then we add that back, and you wind up with original sound, except for that as you start boosting the mid-range, you get only harmonics from stuff that's not going to alias. And that's focus. The reason this says figure is because it's like, okay, well, if that was the ground, then this is the figure. They're overlapping and fill the same space. It's a figure versus ground distinction. It's an artistic term. Coils is up here. The only thing that's different about this is that it's a negative, and I can deal with that separately or not at all, because that's the offset, and we're going to do a different thing with offset here. And we've got a reset and we've got the code. So let's copy those things over as well and see whether we can get it running, which is very likely that we can, because this is not going to be hard. You'll also notice that this is the original form of the dithering to floating point with this little variable that gets changed. And I've just copied this bit. The new version does this. It does a random thing, so that when we instantiate it, each separate plugin has its own random value. And that's useful too. So we've got that. Now we can just copy everything in process. Actually, no, we don't want to necessarily do that, because this is an older version of that, and it might be an older version of some of the support code. So instead, let's grab this. That's before the while, that's before the actual loop. We're gonna want to use overall scale most likely, but we don't actually need that. That's there by mistake. The FP temp isn't really happening. You could do that if you wanted. No reason you couldn't. You could scramble those in any way you'd like. Every way you scramble them might sound a little tiny bit different. Whether that is better or worse is kind of up to you. That's kind of artistically using stuff. So here, let's copy this stuff over, having just made this. We will also comment those out while we're at it. And let's allow it to complain Otherwise, I might get confused and not amend these properly. So here's how the template builds. Builds as just a gain plugin. There's a dry wet control in there as well. Here's our current dither. Let's have a quick glance and see whether this looks like it's not the same. No, it was the same. The 32-bit floating point dither is the same as in the previous. So what we're going to do is copy all of this, including the commented stuff. And since it's the same, double dry sample, I can change that to long double again, I think. And now we don't need coils to be open anymore. Instead, I'll kind of scooch that over. Here's the one that we open. We'll go to the build folder. Oh, that's not right. You can delete build folders quite safely. In fact, here, let's demonstrate something else. I mentioned doing terminal. We can go to this folder, and I have a little thing that I've got here. This is a terminal thing. It says find.name build, and then everything that it finds that's called build, whether it's a file or a folder actually, it goes rmr, it deletes it, and it finds everything called build. So when we do this, and we're in terminal, we've gone to this place. See the Coils 2 under here? See how there's a build folder? See how it's not there anymore? And then, of course, if I build, it will come back. The reason I made this, and it also says no such builder directory, which is kind of silly because it just deleted it, but I don't mind. It's kind of weird. And so now we've got some stuff in here which is wrong, so it's time enough to go and fix it. What bothers you a lot? So we're going to comment that out. Now it will actually build. It will complain about unused variables, but it will build. So here's what we've got. Apart from Coils 2, go into the build folder. Since this is the older computer, we can run this. And we can see that if you open this and go to audio units, we will now find Coils 2, because the older computer can actually immediately access that rather than having to reboot. And this is the same as what Coils is. So we'll quit out of there because you have to quit. We do have to quit the program to get it to find a new plugin. So here's what we're doing. Coils is actually using a sample rate. It's using a sample rate at 600 hertz because why not, I guess. And it's using a set resonance frequency. We can fool with this in future. And what it is doing is, the reason it says figure, and I talk about figure versus ground, is this is the opposite of focus or some of those other things like unbox. Rather than distorting the mid-range stuff, Coils is specifically distorting the not mid-range stuff, and it's got a very low resonance frequency. So most of what we hear, in fact, we can probably So if we do this, temp sample is giving us the midband. And then this adding is adding the inverse. So what we can do is take slider 4 and slider 5. And you can hear what it's actually doing, which seems worth doing. I believe that'll build and run. Yep. Less complaints because now I'm using some of that stuff. And now slider 4 and 5 show us what the various extremes are. Well, let's do an alien kittens to see what we got, because it's more wide-ranging. I am still curious, Bro77, at what was bothering you so much. Whether you had the plugins in the right order. Yeah, it's free your mind, man. Put them in any order you like. So 4 and 5 are now. 1 is the same as before. This is only the stuff that is getting distorted. And this is only the stuff that is part of the mid-range. And that's a dry wet. So let's get in here and fool with some of this stuff so that wet is now labeled properly, and let's see. And then 4 and 5. So the one is our mid-ranges, and the other is the inverse. It's the stuff that's getting filtered out. Hey, capsicum kid. Let's use 3 for Q factor. Now that we've got those labeled, not only that, I've got another thing I intend to do. We've been caching this because this is not moving, but that is not the case. We're going to want to have that be moving, so we need to not be caching this anymore. So now we're going to do that every sample. It'll be a little bit more costly, but this antique computer is still pretty good at being able to handle this stuff. So we no longer have that. We're not caching that because it's going to be a lot more active going forward. Yeah, random seed in the floating point dither, I just showed you it. It is up here. It's this line of code. Any of my code that has this in it is doing the random seed in the floating point dither. I'm already doing it. I think Coils is so old that I didn't have that going on for that one, but in this one it does. The template now includes it. So let us see. We'll build this, we'll copy it. We'll throw on M007 slider, huh? Right. Well, it is a real term, or I'll show you what it does. So we're going to want that to be smaller. See, when we increase the Q, we're doing a mid-range frequency for doing this stuff. So this is what I had. This is like my notion of the clean part of what a transformer algorithm sounds like. But we can go quite sharp, really. And that is keeping the clean part as a much narrower band. And inversive mid is basically the distorting the stuff that happens on the opposite of that. So when we boost heavily, that's giving us the difference. Like this is quite undistorted. This slider is not very good either. Like this is some distortion. And then we're just like clamping it further and further. It gets more and more clamped, but it's all happening in the tiniest little output stages. So this is not a well-designed slider. This is long before I was doing this stuff on live streams. If I had been doing this on live streams, I think I would have noticed. It'd been like, oh, this is terrible. Let's not do that. But here's what we get is cranking it up like this. One of the things we're getting is a wave shaping behavior. This is like a sine wave algorithm, so if it is too high output, it's doing a wave folding. We don't necessarily want a wave folding, but we are getting a wave folding. So that might be worth checking out as well. And again, as we crank up Q, it becomes more of the signal, like no boost. Now we're hearing everything except for a narrow band of mid-range. Be in this. Low Q, everything is in mid. High Q, and this isn't even all that high of a Q. We've got a more narrow mid-range, and the part that the mid-range is subtracted from covers more of a range. As you can hear, the way I had it starting out, there's some extreme lows, there's some extreme highs, but mostly there's not much there to be concerned with. As we get more audio in here, the boost goes into a crazy wave folding. This is like what you get out of a Eurorack module. Modular synthesizers doing wave folding. West Coast synthesis is this. It's wave folding. It's making higher frequencies happen. In fact, I can super demonstrate that with the sine wave. Check this out. Now that we're doing this in a way that we can exaggerate it more. Here's our low frequency. Wide Q, so we get lots of this, and then wave folding. It's wrapping around more and more. How much more and more? I'll show you. This is what wave folding does to a sine wave. It's also a really poor design for this boost control. Like full crank, everything that's happening is happening within the last like 100th% of the control, so we're going to fix that. But I think one of the things that we can also do is fix the wave folding. And let us do that by doing this. we're gonna refactor this a little bit until I can see what it's doing easier, because this is crunched down into a very small algorithm. It's nice. I think the idea was I wanted to have it like a line of code so that I could put a transformer emulation in things when I wanted to, but it's not worked out well enough for that to be useful. So instead we're going to do this. I don't believe I'm using that as a number for anything. Now that's going to do the same thing that we already had. It's still doing a wave folding. And now we're going to take away some of these parentheses that don't do anything right now. Boost is doing a thing. We're dividing by boost, so 1.0 minus pow get parameter 1, comma 2. So boost gets smaller as we crank it way up. I think we don't need this. This is just making it be harder to do. So how are we implementing that? It's all fairly... See, this is kind of like Spiral in a way. This is doing a thing. We're adjusting the overall volume of this. Seeing as that happens after everything. So that was just on top of everything else. That means we have another set of nice little parentheses. You can see these ones apply here, and we can now take these out, and we've got a slightly simpler algorithm. And we've got this minus this. So once I've done enough of this, I'll show you that it still makes the same noise. But we're making it in such a way that we can make a little more sense of it. So we now have dist. Dist is this. Dist is sine dry sample, so we can split that out as well because that might be handy for confining it. I often use the term bridge rectifier for this stuff. Hang on. Hang on. I'm trying to figure out which is... Yep, there we go. This is how this is going to work. Boop. And boop. This is all still going to do all the same things if we have our little semicolons at the end to show how it works. This is the same as that single line of code that was much more complicated. We've just busted some things out into separate variables and used them. So the whole point of Coils was to do this thing called offset, where you'd be able to adjust whether it was doing even harmonics, but we want the offset to actually move now. So let us just go and firstly make sure that we do still have the same thing. I don't actually know what remove the extra sign, a sign in the biquad means, but see, some of these comments, this is the same as I had. I think there was a level of feedback in there somehow, but I'm not exactly sure. Trying to figure out what the hell I meant. Distorts like a rail transformer. Oh, you ain't seen nothing yet. I'm going to see if I can take that a little farther. And this is a commented out thing, which is the same as what I already had. We're talking about what we already know we're doing. This is a simple biquad bandpass filter. Again, it claims to be distorting like a rail transformer. We'll see about that. We're going to try to make it go more. Since we're not using a high Q, we can, well, the extra sign I assign is not on the, oh, I know what I meant. We're not using a high Q, therefore we cannot run the entire biquad filter inside an instance of console. That's something that I was able to do, but the thing is I've kind of stopped doing that because running instances of console, it's good to run the aliasing filter on it. So this entire comment is old school. it's from a while ago. Let's simplify this out. Put in some spaces so that we can see that this is the area we're concerned with. And this is the filter. And this is our new distortion place. And we can build this. Runs fine. Let's see if I was right about the stuff I was talking about when I said that I was going to take that power function out to make it handle better. Here's what I mean by that. See, it's not all sitting in the last 100th of an inch. In fact, the power function would be doing the opposite way to do it properly. That might be a fine idea. But wait, there's more. Remember how I said that bridge rectifier was doing wave folding? That's because we're sending stuff into a sine function that is way beyond what it's supposed to have. And I've got stuff in other plugins, maybe on the desktop, maybe not on the desktop. Well, in that case, I will go and find it. I have other plugins that use this kind of thing. So let's go and find like an instance of density or something. Airwindows plugins, old school AU. Let's open up density and see if that is the one that we want. Might not be. I might be better off looking at a version of channel. But I'm looking for a way of confining this bridge rectifier thing. Do we have it here? Yes, we do. This is the number we're going to want. So in order to have a hard clip instead of a wave folding, the output must be between negative 1.57, etc., and positive 1.57, etc. And the reason that bridge rectifier is called bridge rectifier is because I've often implemented it as absolute value. See, fabs. It's not really necessary for a sine, though. I used to think that it was for some reason, because I was being silly and wrong. But we can just take this. That's exactly what we need. And if we do that, it will hard clip on one side and wavefold on the other. So I'm going to do the opposite. I'm going to do negative And now that we do this, you will see the result. And I have another thing in mind. I'm thinking that maybe I want to do this rather than with the sine function. I'm thinking maybe we can do this with the density function. That might be cool. But for now, let's build it and demonstrate that it did the thing that I said that it would. We'll use a sine. And now, it's not wave folding, it's just clipping, which looks like this. So that's what I had in mind. So what else is this doing? We're clipping, that's for sure. And here's the part so this is interesting. Let's fool with this a little bit. Firstly, let's comment this out so that we can make it be louder. And we're going to start seeing what starts to happen when we fool with this. I don't know. I think this is a very different kind of thing. That's the thing that belongs in channel. The crossfading into channel, into spiral, and then into density is something that is part of what channel is all about. This is more like McAtee. This is more like finding the correct distortion thing to make it sound and act like overloading a transformer. So here's the deal. We've got our distortion function. If we don't do this, then we'll have it boosting into the relevant thing. The reason we have it doing this is because we're doing the suppress the clipped stuff hard. And that's the way that this particular transformer emulation works. If we don't have that, we get just a straight distortion function. I'm tempted to actually just leave it, but for now, let's fool with it with just a notch filter and see what the actual distortion part does. Back into here, we're going to work with sines for the time being. It's going to end up being a lot louder, which is fine. You'll be able to hear it better. Maybe not crank it up that much. That is indeed pretty loud. I can pad it on the output. And when I do offset, we get really strong and striking weird noises out of there. So let's see what it does in these two extremes. If we do offset this much, it looks like that. That just looks like a soft clip to me. If we do offset the other direction, what else do we get? Oh wait, the reason that's actually 0. That doesn't go to -1 at all. So let's see what real offset looks like. And it looks like that. So if we're doing this type of offsetting the clipping, what ends up happening is we have our waveform and it's being pushed through into here, and then since we're offsetting after the clip point, so let's undo that firstly and then let's get out of here, because that doesn't actually make all that much sense. So here's what we're doing. We're doing this in two different ways. Bridge rectifier here will stop this sine function from going beyond its ranges. And what we're doing is we're taking this thing and then we add offset to it. So let's do that in a separate place. Instead of doing sine wave this plus this, let's do that, and then do the sine function on just this. Then once we've done that, we do a minus sine of the offset. What that'll do is if it's a small amount, it's going to stay relatively consistent, I think. Let's find out. I'm not entirely sure what all of this will do. That's what makes it interesting. We're kind of refactoring it and simplifying it and stuff, because this is one of the ways of getting into different sounds and behaviors. And we're going to get this visible, and we're going to listen to what happens with some of these. And again, we don't have offsets in both directions anymore, but we were going to be making that part of the waveform. We're going to do hysteresis, and that's different. So offset can go up this much. And that is increasing the size of our output, possibly quite a lot. With no offset, full crank gets to be like that. But with offset, it goes here, so let's have a look at what that looks like. Sure enough, so if we do offset, it's like the transformer, or whatever we call this, is going to be forced into distorting in an asymmetrical way. That's what the offset thing was designed to do. The fact that it did it in a weird, crazy wavefolding way was just a thing. But this is closer to what Coils was meant to be. And it was meant to be that you could run a sine into it. And if there was an offset, if the transformer had a magnetic charge on its armature so that it only had so much saturation to go in one direction before it would just clip out, you'd start seeing this. And it would clip on this side much harder, and as a result of that being an offset, it would not clip on the other side, and that is what we're seeing. So it turns that into the other thing. That is in fact working. And we can take dist times equals boost anytime we want. And what that's going to do is take it back down to the size of, like, instead of boosting into saturation, what it's doing now is more along the lines of clipping into making stuff quieter. And we'll see the result of that in our last half hour or so. And Coils 2. Now if we do the same thing, simple distortion, or lots of offset. Remember, the way this works, this is mid-range and inverse of mid-range. Mid-range is this, and it's a narrow band, high Q or low Q, whatever. And then inverse of mid-range is the lows and the highs. That's how we're getting this sine. So when we boost it and then compensate for that boost, what we're doing is we're setting it up so that it clips harder and harder into silence. Like, there's her silence. We've clipped it so hard there's nothing there. And if we have offset, we wind up with the clipping factor of the stuff that was the outside edges of the mid-range is still clean, but this stuff is more saturated, so we're saturating mostly the lows and extreme highs and letting the mid-ranges through. And with offset, we're saturating it asymmetrically. So it will let through. I can set it up in such a way where it lets through. A hard offset, so it's all in one direction only. I can more or less hear the point where it starts clipping on both sides. So we're going to clip on only one side, and that's what we get. And it's actually still a little bit of clipping on the other side, but it's much harder on the first side. There. We now have a transformer modeling that more accurately clips rather than the rather primitive thing that we had going on where it was doing a wave folding behavior. Original coils only make sense in the most subtlest of subtle applications. It's really kind of intense that way. Let us set this up to quick little change here. Okay, let's also make it have more range on the eensy weensy tiny whiny section. Not that you're going to hear it, but so again, here's the deal. We might end up widening the range a little bit too from the cue that we had. Back to recognizable music, but we're still in that zone of being able to listen directly to stuff. So here's offset, here's cue, this is what it normally is, this is the part that we distort. Mid is acting kind of like dry in that we don't distort that at all. And we now have a broader range of being able to apply this saturation. And we can also throw an offset on, which is going to shift where that's clipping. And that's probably in a good enough range for being able to apply the hysteresis. In fact, it'll be more effective the subtler it is. If we do this properly, yeah, that is exactly right. I was talking about that in a recent week. If we have a degree of clipping that is not super high, offset will cover more of a range too. Offset covers quite a wide range indeed, and it ends up looking like this. Gonna want to undo that. That's what the guts of the transformer model ends up looking like. It's allowing these big swings. Dirk, that's not how this works. Because, here, let's undo this. Because the way this works is not monitoring that directly. We got mid, we got inverse of mid, we got Q. It's normally meant to work like very subtle effect. Instead of makeup gain, it's makeup anti-gain. The harder we distort, the more it's just clipping into death. Because what we're hearing is this. It's the mid-rangey stuff that's supposed to pass through cleanly. without any distortion, because the idea is the transformer lets mid-rangey stuff through with a great deal of purity, and we want to pad down the other stuff so that, I don't know if all those Portico boxes are going to go way up in price. I actually went and bought a bunch of the op amps they use in those Neve Portico boxes, which is not to say that I have the transformers, because the transformers are much more expensive, but it's possible to get some of the parts for those things. And Porticos use a quite accessible op amp for their gain stage stuff. The hardware things that I'm going to start to do might explore areas like that. But again, what we've got here, this is our default Q with no offset. If we do the boost, sounds kind of the same, right? Because our Q was very subtle. But if we do a very high offset, a high Q, without boosting it, it sounds the same. But then as we boost, you're going to start to hear that saturation, because it's covering more of the range. And then as we do the offset, so rather than makeup gain being a thing to make the distorted stuff be louder, we're trying to find the sweet spot in here, which is now more accurately set, between completely frying the transformer to death. We're hitting it so hard that we're just getting complete splat. Or, see, this is all how hard you're hitting the transformer rather than how much crunch you get on the output. So, not hard at all. Harder. Super hard. Complete obliteration. And if this doesn't sound exactly like it would sound if you were literally overdriving a transformer, that's okay too. Because it's supposed to run kind of like this. And you would never know there was distortion. You can't hear any of this unless I let you give a little more Q. And this is where you start hearing it. Yup, U-Tree Magic, you got it nailed. That's exactly right. So the question becomes, now that we have a Q factor that is high enough to hear what it's doing, how much of this offset do we use? This is just plain distortion. And this is lots of offset. A lot of second harmonic. And this sounds like smashing the heck out of a transformer, while still leaving mid-rangey stuff resonant and powerful. And the answer, of course, is no. No, not at all. We're not going to do it like that at all. Instead, what we're going to do, or we're going to give it a try in the last few minutes of doing this, is can we make it so that as we start to distort, we are carrying along a factor that will give us this hysteresis. Like, we start distorting into the sine wave, and it pushes the hysteresis factor this way, so that it makes the waveform turn into this shape where it's a sort of a pointy edge, and then it goes down, and it's able to go down a lot farther before it hits the pointy edge again, and it makes this funny sawtoothy thing going on. That's the shape you get out of a transformer. We have sine waves. Let's see what we can do. First thing we're going to do is make a stored up variable so that we can kind of smooth things out. And we can call it hysteresis. If I can spell it right. It's not right at all. Oh my god, how do you spell Hysteresis? That's how it is. And we're going to save that, and we're going to say and we're going to blank it out upon starting. Yeah. You know, Uncle Jesse, one of the neat things that happened to me at one point is I had a user back in like the old Kagi days, and I saw my user's name in a Mythbusters show as one of the audio engineers. I was like, yeah, my dude. I get excited when I see people that I recognize and know as folks that have used my plugins in media or whatever. I get such a huge kick out of that. So like, if you can help it never be a secret weapon user, if you can help it at least tell me that you're using stuff. And then even if I don't make a big fuss about it or like blow your secret weaponness or whatever, then when I see you succeed, I can be excited too and be like, yay, I helped. So there's that. So hysteresis equals 0. So what are we going to do in here? We are not going to make offset be equal to param2. Offset is going to be something else entirely or nothing. We can probably do this experimentally. Firstly, let's go and copy that difficult to spell word. Boop, there we go. And now everywhere it says offset, I am going to replace it with hysteresis, assign hysteresis. These are also the places where I can put in like drive or something. And there we go. This is the correct thing. How do we affect hysteresis? We affect it by bridge rectifier. So what we can do is, let's take another slider. We had slider 2, was it? Yeah. And I copy this over. We're going to use that, and then we're going to be at a higher sample rate. This will happen faster because there will be more samples being applied, so I'm going to want to make it smaller. Overall scale is larger if it's a high sample rate, therefore we do divide it by overall scale. I'll use a silly word for that, so let's use something else. Amount. What am I trying to do? I'm going to, we're going to be applying an IR filter, so good enough. Our amount equals get param2, so 0 is going to be nothing much happening. Hysteresis, I guess. I'm not sure if it's correct. Hysteresis. There we go. So we're starting from this. I'm going to fix this later. And this is what I mean by I'm going to fix this later. Okay, so which one am I going to want to be? 0 is like no effect, so very rolled off. So it's going to be mostly hysteresis times and there, now I have a handy little IR filter. And if we increase slider 2, which is IR amount, let's change it while we're at it so that we can see what it says. It's not really boost, is it? It's more clipping. So saturate. And that should work. Seems legit. So far so good. So what should happen is as we turn this up, this factor starts moving around, and weird things could happen, but let's see what this does. We're getting on towards the end of the day. I can't stay for lots of extra hours. Oh, hello. I did not camel case that one. There we go. What was I doing? That was just silly. Now, let's see what noise it makes, and then we'll see what it does to a sine. It is kind of like watching a virtual breadboard in action. That's what coding and hacking this kind of stuff together is. It's great. So IR amount, that's going to start out as nothing. High Q. Let's listen to just the inverse. We can saturate it, and now when we turn up the IR amount, I am definitely hearing more wavefolding in there. It's brighter here. We get more lows here. And then as we dial it back, it's doing a thing. And the funny thing is, as far as actual parts, that's what the DIY stuff is going to be about. You pick the right parts to work with, and they're not nearly as expensive. The parts that are expensive are things like knobs. If you can do without like good knobs and good jacks and good cables, it's amazing what you can make. So let's get out of here. Let's get our sine together. Zoom in on it and see if we can make a shape like this by a little experimenting. I wish I could watch the waveform, but I can't. But wow, it very quickly kicks in, doesn't it? Oh yeah, and I got wavefolding in a big way, but if I didn't, what would I have? Interesting. Looks like we have the right basic thing, it's just not working in quite the right way. We want a slower effect, so we'll fool with some of the parameters. Let's have a much slower IR amount. Check it out. This is what we get when we're doing limited distortion here, and we quickly see a result when we start doing this. So logically, if we were to, the click is looping, do that, what do we got now? Okay, that's interesting. Having it combined with the raw signal would also probably be useful, but I'm not sure. Like if you take this, well, let's try it. Undo. Let us not just listen to the stuff that we're filtering. Let's also listen to the sign. Mid. Come back in. Not much different. Let's wipe the cue back down. Okay, I think what's happening is we're doing the opposite. We want the top of the wave to be this shape and then to fall off faster. What's happening is we're hitting slower and then peaking out here and then going down. So I think that's enough to do a quick change. This is the change. We want the opposite of what bridge rectifier is doing, and we want it in very small amounts. How small? We're probably fine, but I could get a little bit more angle on this by going like this. There, now I can take what number I have, multiply it by itself, and then that's the constant. Let us build, let us run. I'm probably not going to be quite finished at 1, but I didn't have somewhere to be at 2, so we can't go too much longer. Back to our sign. Are we going to get the appearance we want? Looks kind of the same. So let's crank it up a little bit. I have no idea whether the filter is phased. We're not even concerned about that. We're like frequency modulating things. This is not a question of distortion. The whole thing is a giant pile of distortion. Like this. Actually, no, not like that. Like this. Well, that's interesting. I've got a node. It makes a sound. That's going to be because IR amount gets high enough and it no longer responds to the bass. So what do we have here? I feel like this is still not, this isn't going the right direction. It's building up here rather than falling off here. One more inspection, I think. Hello, no, that's better. That is what I wanted it to do. The idea is when you're making this funny sawtoothy shape, what's happening is you're going up into this, it is clipping, it is pushing the overall, as we get into the clipping stage, what's happening is it's pushing the entire framework the opposite direction. So we get into a clip easier, and then it clips and it goes down. It seems to be rounding off a little bit, but that's another story. Keeps going down, and then it has to go a little farther to get into its clip down here than it would have if nothing was happening. And the question becomes, like, at what frequencies does this happen? Because it theoretically could happen at all of the frequencies, meaning that maybe the IIR thing is not correct. So we have that on a slider, so let's defeat it. All IIR amount means there's almost nothing going on here at all. It's just taking the factor in directly. Okay, I'm kind of satisfied with it, but I feel as if maybe there's more to be done here. I feel like there's a delay factor in there. So I'm trying to wave shape to make a particular thing. What if it was, no, let's not even do that. What does that wave foldiness look like? Oh, it looks like this. Yeah, that's not right. Okay, first things first, let's make the wave foldiness also not distort. We've got bridge rectifier plus hysteresis, then minus sine hysteresis, but we should also be clamping the hysteresis, whatever it is. Goodness gracious, who knows? I got other fish to fry right at the moment. So you know something? Negative bridge rectifier. Well, no, hang on, that can't be right. Got bridge rectifier, we're doing this for the distortion. Hysteresis, however the hell you pronounce it, goes this. Bridge rectifier plus that. We're clamping it. Then it does this. Basically what I want is a quadrature oscillator. Basically what I want is a phase rotated. Let's do the first thought that came to mind. We'll clamp that as well. Why not? Might have interesting results on different frequency ranges if we play our cards right. But this will stop that behavior. We're doing it separately with each parameter. This is still engaged, so we can still filter it. And let's play with this toy now. I'd really like to get a result rather than just having to give up today and stop. So here's what our invert sounds like. Distorts lots. When we apply it, it looks like this. That seems pretty normal. So if we add med, hello, look at you. You look exactly right now. Check it out. I'm looking for this waveform here. Oop. This sawtoothy thing, which is what the shape of a transformer does. Look at that. That's a sawtoothy thing. Not even doing anything with the filtering. Let's try it in other signs while we're at it. Here's a high sign. What do we get with exactly the same settings being a pretty high Q? We have mid and inv of mid, and it's mostly going to be inv of mid. Apply and close. Our waveform looks like this. Not quite what I expected, but it's cool. It's something. I think maybe it's getting around time to try this on an audio waveform. Because at some point you get this kind of stuff working and then you start dialing it in based on listening to stuff that you know how it works. We have a nifty little wave shaper here. So move some of that stuff around. There's actually functions that you can use, which is like, okay, clamp bridge rectifier between these two things. I'm just doing it with the statements to be primitive. That does the same thing as the other. Not only that, let's simplify this a little bit more. Now we've got this, which means the same thing. And we'll build it. Let's finish this up. Do I use any hardware for mixing purposes? Yeah, for a long time I was using a fairly fancy Heritage audio mixer. I ended up with an intermittent problem in one of the pots, which was depressing because it was so expensive. But what I'm shooting for making things so that I can use only the DAW for all the mixing purposes and everything, and only the preamp and analog to digital converter is necessary. That's my target. That's my goal. I'm trying to get to that point. Let's build. Let's see, we'll go to components. Need to quit out of the program first. Thank you. There we go. Now let's fire up one of these just so that I can check and see whether I had IR amount cranked up so high that there's no filter in here. This is just only the input signal. So the question now becomes, yeah, so I can do that. What happens if we use audio and start fooling with this on an audio wave? So here we're going to have mid and inv of mid turned up all the way. Yeah, the mixer I was using was a Heritage Audio mixer. It's a company out of Spain. They make a compressor called the, oh God, I don't remember, Successor. I was using that too. And I forget the name of the mixer that I was using. It was a sort of big rack mount mixer with all knobs instead of sliders. Very old school looking. So back to this. So if we distort this way, this is what it's supposed to sound like distorting into a transformer. If we use slightly less Q, this is what we defaulted to. Honestly, I can say that that's somewhat convincing. It's kind of plausible. We can pad everything down a little bit like this. Doing this much saturation is bad because we actually have nothing. Also, the 1.507 is not a voltage, it's just where pi, it's where a sine function clips out and stops. Nothing to do with the voltage. Now let's introduce the Q factor, bring a little more of this saturation in. Now we're hearing more of the saturation in there. We're letting through some gain. Slam the transformer like this. If we're mostly just the output gain and nothing much in the mid-range, slamming it sounds like this. That's maybe what it sounds like. Let's also hear what it sounds like using the IIR filter. So here we have highs kind of suppressed. Yeah, with this really low, the brightness comes through more. With this really high, the brightness saturates really hard. So brightness coming through here. More of the distortion on the brightness. I don't know though. So let's set Q up so that it sounds like we have a lot of power and intensity coming through while still being able to hear all this distortion. And pull it back. Like this is the full clip. Now we can hear the hats and things. Harder distortion on the hats. Less distortion on the hats. I feel like allowing a certain amount of IR amount is actually good. So let's stop doing that. Made this laptop run really hard. I've got this itty bitty laptop and it is kind of an antique. So the way I do stuff is I might not be able to do a full mix on this, but I ought to at least be able to run it on a 2-channel thing in Twisted Wave. without the laptop completely falling over and crashing. Let's go back to my drum sounds. We like these, yes? We're also at 986K now. So you'd put saturation up higher to make it obviously going into the transformer kind of hot. Putting IR amount high will cause this to affect the like a really narrow Q. Oh yeah, that sounds weird. Also, I can turn this back up because nothing's anywhere near clipping. Raw and super distort. So we have the mid-range punching through. That mid-range gives us some of our tone. And if we have a very small IR amount, see, as we push harder into it, the highs start to be really crushed. So the question becomes, now that I've got this into a zone where I can hear it smashing the highs flat to some extent. Yeah, if we have a small IR amount here, if I crank it up, it starts to sound kind of brighter. I think it's because it's letting too much of that through. See, we're flattening the hats right out. But then if we do this, it's like there's an overtone poking out there, which isn't supposed to be there. But it doesn't take much to smooth it out. If you got a funny overtone here, but by here it's already rolled off. So we don't actually end up with that much, but this is still a relevant control. This is helping it just bludgeon the distortion. Undistorted to super distorted to a broader Q. So these are ways we can voice an imaginary transformer to make it do what we want. Like this becomes kind of a cheapness factor. And the default is like very clean, but we rather quickly get into your cheap telephone transformer thing. Like in this case, it's like, okay, we're running the entire signal through a telephone coupling transformer. So it sounds like this, right? still kind of does. And then this super high quality transformer, huge, giant. We could reverse it and have it be transformer size. And then this IIR amount here, it wants to be a very low value. You can turn it up just enough that we really clearly hear what's going on. A little too edgy. So here's my question. Do we have a correlation here? Q is supposed to be a very small number. If we turn Q up, it gets more telephone coupling transformer. If we turn Q down, it gets bigger. At the same time, this IIR amount thing, yeah, quick little experiment. So what we've got here is two different controls. Here's one, here's another. IIR amount needs to be less than 1. Resonance needs to be small too, but we can do that by going (0.023) or indeed less, or indeed give it a little more of that going on. And the resonance now hovers around this smaller factor. It can be really quite wide indeed. We can also give it a range to start with where it gets even cleaner, meaning that it's even more just dry. And it only goes up to this as a max. Here's the question. What if we did this? Just start with that. It does still need to have the overall scale in there, but probably not all that much. And we will have that be this thing that goes up to roughly around 0.5. I didn't really want to take it much farther. And that means it's going to emphasize the lows more, the more this goes down. And we'll move it to param 2. And we'll call it cheapness. And then these, I don't think we really need these anymore either, because I've demonstrated that. We might actually be getting towards having something only about a half an hour longer than I intended to. Let's find where it says slider 4 and slider 5. There we go, and there we go. Simplify that just a bit too. And away we go. So if this is absolutely amazing, I'm going to declare victory and say good day. Where's what we've got? We've got Coils 2, saturation and cheapness. None of this other stuff matters, although the dry wet still does. Zero cheapness means big old transformer, super clean. Saturation, you probably don't always want to go up to 1, but what we can do is cheaper and cheaper. And where we really get cool is when we start doing partial saturation, because this is not meant to be a distortion box, this is an elaborate tone shaper. So partial cheapness goes like this. You kind of set it up like, okay, if we saturated this all the way, how cheap would it sound? And be like, okay, I want this much of my low is still here. This sounds about right, and then you start pulling it back. You got a pretty good range. That has a real color and vibe to it, I think. Bypass. It's a lot cleaner, less transformers in there. Technically what you're hearing is already going through 2 transformers because it's going through an API preamp. But more transformers. More chipness. And it winds up sounding kind of funky and mid-rangey. Yeah, I'm feeling this. Enough with that. Let's go back to Alien Kittens. Because of course we are. That should show me things. All that low end. So no cheapness to full cheapness. Super cheap. This is your telephone coupling transformer right there. We've actually got peaks out of here that are hot than the original signal. Listening to some of the reverb. And of course, remembering that full saturation, there is a download link. It's never about full saturation. That's just a very limiting factor. What you want is a combination. There's the raw one, and running through a transformer. Yeah, there's a certain sort of swing going on in it. Yep. So no effect, and little flat. And remember, turning up saturation doesn't make everything louder, instead it does this. You can't hear this, but I'm hearing all kinds of funny stereo stuff jumping out now. Let's quickly visit this on 96K. And just for laughs before I go, check this out. Here's what it's doing. So this is the change that's happening to this stuff when you do various things. No cheapness and full saturation, we got this happening. Actually, with full saturation, you're always going to just get this. But stuff starts getting interesting when we're partially saturated. There's going to be a kind of butter zone in here where this is what the transformer is catching and eating up. It can be highs. Funny mid-range frequency things. Bunch of different stuff that pops out. At low cheapness, you're catching more of the symbols. At lower saturation, other funny things start happening. There you are. Coils 2. So I'll work on getting that out, although I'm having to work awfully hard getting all of these M1 plugins. But I'll be putting that into action, and it should be good fun. So on that note, I will say good day, y'all. And I'll talk to you later. Bye-bye.